Hello and welcome to 5-Minute Math. Today we are looking at the third grade concept of representing multiplication. This is standard 3.4e in the great state of Texas, and we are using item number 29 of the redesign practice online STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a very simple equation. 3 times 7 equals unknown or blank. And we need to find which of these representations is the best way to show that. Okay. Well, let's open up our graph draw feature. We'll expand it so it covers the entire problem. Make it a little bit more transparent. All right, so let's hit this draw button here. So we can kind of draw all over it right here. There's no eraser, but you can reset to erase the entire thing if you need to. So 3 times 7, what is 3 times 7? Right, that's a basic fact. 3 times 7 is 21. Okay, so let's see what we have here. Okay, so let's look at A. 7 times 7 times 7. So 3 times 7 means 3 groups of 7. And you know what? A is tricky. A has 3 sevens. But when we're talking 3 groups of 7, this is what we're talking about. We're talking about 7 plus 7 plus 7. What we're doing is relating multiplication to repeated addition. 7 times 7 times 7, look. 7 times 7 is 49. And then if I want to do 49 times 7, well, we can do that. So 7 times 7 is times 7. That's going to be 63, right? And that's 28. Carry that. Add that 6 in. Look at this. Holy cow, that's 343. So I am going to guess that students that get this question wrong probably are going to choose A because it looks really good. There's 3 sevens. The problem is the operation. It's times times. It should be plus plus. All right, and that helps by us actually working out the problem. 7 times 7 times 7 is 343. All right, the B is just kind of silly. I mean, I see what they're doing here. Look, there's 3 little circles there. There's 7 little circles there. That has nothing to do with 3 times 7. First off, I'm looking for 21 circles. Really, this is 10 circles. It's a 3 and a 7, right? If I move this circle right here, and if I move this circle right here, I've got a 10 frame. So having 10 circles doesn't help me. So it's not A, it's not B. All right, so I'm counting 7, 10, 13, 16, 19, 22, 20. Now that's random. This is 7 groups, and we're counting by 3s, starting at 7, right? So I guess this is the 7s and the 3s. So first off, why are we starting at 7? Why aren't we starting at 0? Because you see that plus 3, right, doesn't work because the gap between the 7 and the beginning number, which is a 0, that's a plus 7. So the pattern doesn't extend all the way back to the very beginning. And secondly, we know what 7 times 3 is. It's 21. Guess where we end? 28. So, no. All right, let's hope it's D. See, look, D starts at 0, and we're making little hops. Okay? So we've got 1 hop, 2 hop, 3 hop, 4 hop, 5 hop, 6 hops, 7 hops. And look, we're skip counting by 3s. 3, 6, 9, 12, 15, 18. All right, it ends on 21. That's good. So remember the commutative property of multiplication lets us flip the order. This is 7 groups of 3. Well, 7 groups of 3 is the same as 3 groups of 7. They both equal 21. So our answer here is D.